Well, hi there. So in this video, we're going to do some practice related to oligopoly. So we're going to do two different payoff matrices. Let's get started. Okay, so the first part tells us we got profit, billions of dollars. They tell us that because bigger is better, right? So we kind of remember here, bigger, better, as opposed to years in prison where we would say lesser is better. And we got Burger King, we got McDonald's. They can raise prices, they cannot raise prices. Does McDonald's have a dominant strategy? Explain using dollar values in the payoff matrix. So let's go ahead and just solve this one anyways. Let's play as Burger King. If McDonald's is raising prices, Burger King can get 10 or they can get $12 billion by not raising prices. So we think Burger King's going to not raise. McDonald's, let's say they do not raise their prices, then Burger King can either raise and get 6 or not raise and get 9. So that means, of course, Burger King's not going to raise. Burger King has a dominant strategy to not raise. Now, McDonald's does know that. So McDonald's looks at it and goes, well, if Burger King does not raise, we could raise our prices or not raise our prices. If we raise, we get 8. If we don't raise, we get 7. So we are going to raise our prices. If I'm thinking that Burger King's going to play irrationally and I am McDonald's, I could raise and get 13, or I could not raise and get 14. So I would not raise in that circumstance. Because McDonald's sometimes raises its prices and sometimes does not, I would say no. And then I have to say why. And that's because we would say 14 is bigger than 13, and we would say 8 is bigger than 7. And so, whoa, get back here. What I'm doing is I'm comparing the two numbers against each other right here. And that way I'm showing the greater that I'm actually making the right comparison, right? Because this is too easy just to say no. You do have to say why, and these numbers need to be correct, right? You can't be messing around with other people's numbers and all that thing. You also couldn't say 13 is bigger than 8 and 14 is bigger than 7 because those aren't the right numbers to compare. So you have to compare the right numbers. Number 2, assume the firms collude, both agreeing to choose the high prices in order to maximize the joint profit at $23. Okay, cool. That is actually where they would. So if such an agreement is not legally enforceable, does Burger King have an incentive to break the agreement? Explain using specific values. So let's say that they agreed to be up here at 23, right? Where Burger King in that deal is making 10. Well, if McDonald's is raising prices and making 13, Burger King's only making 10, Burger King could cheat and get 12 and say, ha, McDonald's, we got you right where we want you. And so, yes, they do have an incentive. Yes, because 12 is bigger than 10. And so if Burger King were to say double cross McDonald's, right, not worry about the Hamburglar or Ronald coming after him because he's got his own Burger King army, then, he's going to cheat because he's thinking McDonald's is going to raise his price. And that actually would put them into this Nash equilibrium down here where McDonald's is in a real pickle or special sauce or sesame seed bun or something like that. Now, number 3, instead of colluding, the firms simultaneously select their prices. What is McDonald's profit? They're going to end up here in this box in that Nash equilibrium. That's because when they simultaneously select, well, Burger King is going to not raise their prices, right? We know that because Burger King has a dominant strategy to not raise their prices, and McDonald's knows that too, and so McDonald's will raise their prices and get 8. So we would say 8 is the answer for that one. That's all we have to say, 8, because we're reading the payoff matrix and we understand the concept. Now, let's take a look at number 4 with this different payoff matrix, Chipotle and Qdoba. Again, payoffs are profits, so bigger numbers are better. If the two shops do not cooperate, what will be the profit for Qdoba? So again, we're going to go ahead and solve this one anyways before we get too far into it. If we are Qdoba and we think that Chipotle is going to go with high price, we could get 105 or 120. So we are going to prefer 120. If Chipotle goes low, though, we're still going to go low. We're going to get 75. So Qdoba is always going to go low, cut them low, make them burritos cheap. Chipotle knows that, and so they're given a choice. When Qdoba goes low, should Chipotle go high and get 80 or low and get 70? Well, they're going to go high and get 80. But if Qdoba plays irrationally, Chipotle could go high and get 110 or low and get 130. So this is actually the same payoff matrix as above. I am sorry that I gave you 2 that were exactly the same. But realistically, it's good practice to get in the habit of kind of comparing these. If they don't cooperate, what will be the profit for Qdoba? Well, Qdoba will get $120. Now, part 5 changes this thing up a little bit in a way that AP exams really often do. It says the town government concerned that food prices are too high. It decides to give a daily subsidy of $20 to any shop that chooses to set a low price. Redraw this matrix and show that additional $20. And so we're going to redraw the whole thing. We can kind of abbreviate a little bit here. And we'll say that's Qdoba and that's Chipotle. High, low, high, low. Now, they get $20 if they go low. So we're going to add 20 plus 20 to every low payoff. And so the high box is going to stay the same, right? That one's the easy one. The low box, we're going to add 20 to each. So that's 95 and 90. Now, here's where it gets tricky. Low, high, right? This low, the first number is coming from Qdoba going low. So we're going to add 20 to that 120. But the second number, 80, is coming from Chipotle going high. So that one's going to stay the same. Now, when Qdoba goes high and Chipotle goes low, well, this first number, the 40 in this case, comes from Qdoba going high. They're going to stay where they are. But the second number, 130, is going to have $20 added to it. So now we have a new payoff matrix that we've drawn here. It is going to ask us to do a couple of things as a result. So we're going to go ahead and resolve it. Qdoba thinks, oh, Chipotle is going to go high, so we'll go low. Chipotle might go low. Well, we should still go low. So we still have a dominant strategy for Qdoba to go low. Now, Chipotle can either go high and 110 or low and 150, so they will go low. Or they can go high and get 80 or low and get 90. And so now Chipotle actually has a dominant strategy to go low, and it has shifted our Nash. All right, so let's take a look. Would Qdoba choose to shed a high price or a low price? We would say low because, and we're going to have to say for both, right? We're going to say for both 140, and I'm comparing these two numbers. If I'm Qdoba, 140 is greater than 105, and I need to make this comparison. 95 is bigger than 40. So that's why Qdoba will always go low. In fact, they still have that dominant strategy that they used to, but now it's additional $20. Would the profits for Qdoba increase, decrease, stay the same? Explain with a comparison your answer in number 4. Use specific values. Now, this is a really common question, and it trips students up every single time because we gave $20 when they're going low. And originally in number 4, Qdoba was already going low, and they were making $120. And so students are going to immediately want to go, oh, they'll make 140. No, they don't. They don't. Pay attention. You can do this. Now, notice our Nash shifted. It's 95. So earlier, Qdoba was doing the right thing and getting 120. And this new incentive actually caused this perverse outcome where the company that was going low already is going to get hit. And they're going to go, wait a minute. Now we're only making 95. It's a bummer for them, but it is true that Qdoba's profit would decrease. And we can say because, and here we're going to compare the values, 120 is less than 95. So hopefully this helps you with kind of working through some of the basics of payoff matrices with Oligopoly. I'll see you next time.